Okay, parent function. This is a new parent function. It's not a line. It's not a V. It's a curve. Kind of looks like a U. Okay? So the parent function, which is labeled for you right here, is f of x equals x squared. That's the new parent. And it is a curved shape. Okay? So what we have to do is figure out how to draw the curved shape in exactly the right way. Okay? So we're going to label a few points. So the grid is a little bit light. So what we're going to do is you can plug in here. We're going to do 1, 2, 3. Okay? So if I plug in 0, I get 0. That's the origin, 0, 0. Okay? If I plug in 1, I get 1. So we're just looking at the placement of the points to make sure we know exactly where they go on our new parent. So if I plug in 2, I get 4. Conveniently, that's 2 squared because it's a squared parent function. Okay? If I plug in 3, I get 9.
Could you just square it?
Because you just square it. Yes. Okay. Now I'm going to do the -1, the -2, and the -3. Notice there is some symmetry to this picture. So if I go to, oh yeah, it's the same. Be better if I had a prettier grid here, but okay. It's the same. All right, so we have a couple vocab words to identify here. 0, 0 is the vertex. Okay? Vertex. Okay? That's this point right there. Okay? It's the vertex. Right? 0, 0. Okay, we have this straight line down the middle of the graph, which is kind of where there's symmetry. Notice how the right half is the same as the left half of the graph. And so this is called the axis of symmetry. Okay, so axis of symmetry. Axis of symmetry. And that is the line that goes right through the vertex, right? It goes right through the vertex. So those two pieces are connected. X equals 0. It's an axis, it's a line. It's not a point, it's a line. The vertex is an actual point. Okay. Now I have to figure out, like, how can I remember where these points go on the graph? Because you have to have this picture memorized. Okay, I'm not going to give you the picture. You have to know the picture. So if I go over 1, I go up 1. If I go over 2 from the vertex, I go up 4. If I go over 3 from the vertex, I go up 9. So I'm looking at how I count these points. So I go over 1, up 1. Over 2, up 4. Over 3, up 9. Is there a pattern to how these numbers are going up? Okay, if I go over 4, how far up would I go? Yay, 16. See if I can do it. Okay, so notice that we are counting squares because it's a squared parent function. If I make this exponent a 3 or a 4 or a 5, it gets a different picture. Okay? X squared is specific to this picture. Notice that I'm only counting one side because it's symmetry. I only have to count one side and then I just bloop, count the points over. Notice that this line down the middle, 2 units, 2 units. 1, 2, 3, 1, 2, 3. There, it's symmetric. So you only need a few points and then you reflect them over. 1, 2, 3, 4. 1, 2, 3, 4. So you have that symmetry to create all of these points on the graph. Now, we're going to need 5 points. You've got to put the vertex on your graph, and you have to put at least 4 more points, which is 2 sets, right? 2 on the right side, 2 on the left side. Okay. Couple more vocab words to describe our picture. Okay. Let's do domain while we're here. And let's do the range while we're here. Okay, the domain of this picture, notice that we've got arrows, is all real numbers. Okay, you can write it in interval or with the symbol. And the range, bottom to top, all right? Now, if you're going to describe range, make sure you use the y value. Okay. Now for the fun word. It doesn't actually need to be a different color. That's okay. Concave up like a cup. It's the shape of the parabola. Concave up like a cup. It's like this. Like this. Opening up like a cup. Okay, concave down like a frown. I'm pretty sure I read that in a calculus book somewhere, like the rhyme. Concave up like a cup, concave down like a frown. Okay, it's a vocab word. It just describes what it looks like. Okay, so concave up and concave down are new words to describe the curvature or the opening. Okay, we're gonna review increasing or decreasing. And we're going to draw 2 pictures that go with it. So we're going to draw a concave up picture and a small concave down picture. And put a little dot on here for the vertex. So try to make your picture look symmetric with the vertex in the middle. And we're going to highlight or identify some different pieces here. So we're going to do increasing and we're going to do decreasing. And we're just going to highlight the parts of the parabola that correspond to that word. Put a reminder on here for myself. Left, read, left to right. That's how you read, left to right. So you need to read this parabola left to right. So I'm going to put my pencil on this arrow, and I'm going to move it from the left to the right. Where does my pencil go up? I love it. To the right of the vertex. So on the right side, right? The right half. Right? Now I'm going to do this one. When does my pencil move up as I go left to right? To the left of the vertex. Okay, that's increasing. When does it go up? Decreasing. When does it go down? The other side. Notice how the vertex is right in the middle. Okay, it divides the increasing and the decreasing parts of the graph. So we are pulling back some of our vocab words from Unit 1. Domain, range, increasing, decreasing. Okay, we're going to have some more interval notation. Right, and then I'm going to label this particular vertex happens to be a minimum because it's the lowest value. This particular vertex happens to be a maximum because it's the highest value. So this min and max is kind of connected to the concave up or concave down. Right? See this? Min. See that? Max. It's connected to the vertex and the opening. All right. I'm not going to do baby steps. We're just going to like jump in and graph with all the transformations that we've already been introduced to. Okay? Because you can do it. I'm going to flip my page because I'm out of space. No? Yes? I don't know. Can I do it? All right, I can do it. I have a little bit more space, so I'm going to start B. Vertex form. Vertex form or transformation form. Transformation. Y equals A. A, H, and K, just like the absolute value graph. We're not going to do B with this one. We're not going to do the B value. We're just going to do A, H, and K. Yes?
Is the only difference between that and the other type is the extra scoring?
Yes. Okay. So how do I know that this is supposed to be the parabola parent function? So this part right here, where you get the parentheses and the square, that's the part that makes it a parabola. If they were bars, it would be absolute value. So this parentheses, parabola, the square is what makes it the parabola shape. Okay, eventually we're going to have 8 different shapes to pick from. Now we have 3, line, V, U. We are learning the U shape. Okay, so it's a parabola because of the square. All right, the A. Stretch and reflect. Now, it's going to change the Y value, right? It's going to change the Y value. The H goes right and left, and it's opposite. And the K goes up and down. Good. Same words they've been since August. Stretch, reflect, right, left, up, down. That's what we're going to do. We just have a new shape we're going to connect it with. All right, so vertex is HK. the axis of symmetry goes through the vertex. See, they're connected. That vertical line down the middle of the graph. All right.
Where's the K change?
Oh, the y coordinate of the vertex. So
Like,
here we go. X, y. There you go. Okay.
Wait, what do you mean? Like, I'm so confused. What do you mean by the Y? Like it changes the Y?
It changes the y coordinate. Yes. Okay. We're going to do 3 total graphs. Okay. We're going to do a little bit of work right next to it. I can fit 3 graphs on one paper. That's what I'm going to do. If you're worried about limited space, you might be able to overlap the graphs just a little bit. You could probably make it work. Okay, here we go. Examples. I'll do them one at a time, but we're going to do 3. Here's what we're going to do. I'm going to give you the equation. Okay, examples. Y equals negative. Right, we're just going to jump in and we're going to do the whole thing. Okay. Once you have this one written down, I'm going to ask you to just like watch while I graph it, and then I will take the, what is this paper called? Then I'll take the paper away and we'll do it again together. So first, you just have to watch it, all right? So you get a chance to see the whole problem, and then I will walk you through it together. Okay, so as soon as you're ready, you can just look up. All right, so this is a negative, so it's going to open down because it's reflecting the y values. This is going to go right 3 and up 4. So the vertex is going to be 3, 4. 1, 2, 3, 4. So there's my vertex. Now I'm going to try to figure out where the points go. Now I'm going to jot down, right, my parent function points so that I know how to count. Now I know it's opening down because of the negative. So from the vertex, I'm going to go right 1, down 1. Right 2, down 1, 2, 3, 4. I could continue and go right 3, down 4, 5, 6, 7, 8, 9. Now there is some symmetry right down the middle, and I could use that to reflect the other points so that I have, in this case, 6 whole points. Okay, there's my graph. That's the whole thing. Notice that I place my vertex before I actually count my points because I don't feel like drawing it more than once. All right, here we go. Now you do it with me. Okay. First thing I'm going to do is figure out what all these transformations are. Open, down. Right 3, up 4. So my vertex is 3, 4. Okay, so I'll pause, let you catch up. That's the first thing I'm going to do. Yes?
Is the the X part of the vertex, whatever direction it is at the end.
Yes.
So if it was X plus 3, your vertex would be negative 3.
Yes. Yeah, it's whatever direction you're moving. Right is positive, so it goes plus 3. Okay. Now I'm going to jot down those parent function points I've committed to my memory. 0, 0, 1, 1, 2, 4, 3, 9, 4, 16. Okay. 0, 0, 1, 1, 2, 4. I'd only keep drawing more if I actually need more. Okay. X, Y. And I know it's opening down because of the negative. So I'm not going to multiply the negative. I'm just going to make sure I'm counting down. So over 1, let me put a V here so that I know where the center of my graph is. 1, 1, 2, 4, 3, 4, 5, 6, 7, 8, 9. Okay, and then I'll just use my axis of symmetry. Axis of symmetry is how I get the rest of my points. I just reflect them over. See that? 3 units, 3 units. And connect in the nice, smooth direction. Okay, so let's go ahead and label this picture with the domain and range.
What are the 2 points that you have on the bottom? Or like what numbers? What numbers is that?
This
What point is that?
is 0, negative 5, and this one is 6, negative 5. So I counted over 3 and down 9. Yes. All right. Domain, all real numbers. Any volunteers for the range? We'll go Lori.
Negative is going to be on the 4, and the 4 is on the close.
Yes. Awesome. Okay. And right here, I'm going to say the max is 4. Connected to the vertex. Yes, Alex.
So, I can't quite remember the, it is like the boxy, thing for the negative and on the box. Does that mean it includes?
Included, yes. Means it's a closed point. Yes, Rand. Yes, all of them do because there's nothing that's cutting off those arrows. Good observation. Okay. The person closest to the window. Explain to the person closest to the door. How did we do this problem? First, second, third. So in your groups of 2, okay, the person closest to the windows, explain to the person next to you how to graph this. Alex, you could turn around and explain it to Adam.
Well, yeah, Mr. Rizzo's already accepted, so like it would be, your main would be all real numbers?
Nope. Always all real. All right, nice job. Are there any questions that have arisen after the explanation? Okay. Yes, question.
Do you count from like the vertex or from like what point you're
The vertex. So the points are always compared to the vertex. Good question. Yes.
What happens if you have a number in front of me like negative like 5?
Here you go. Next example. Y equals 1/2. X plus 1 parentheses squared minus 8. Okay, so I'm going to do the same thing with this one. I'm going to do the whole problem on the sheet protector, and then I'll walk you through it together. So you can see the whole thing, and then we'll put it together step by step.
What happens if it's like not squared instead, like it's like to the 4th power?
Then it is not a parabola.
Are we gonna get problems like that?
Not in this unit. We'll actually learn them first. Okay, here we go. So you're just gonna watch, and then I'll go back and we'll do it together. The graph is going to open up because it's positive, and I'm going to half the y values because there's a half in front. It's going to go left 1 and down 8. So my vertex is this. All right, so left 1, down 8. Now, the half is a little bit tricky, so I'm going to just jot my parent function points down. And I put down a lot of them, okay? And I have to times the y's by a half. Now, personally, I like to plot integers, but I'll show you all of them. So I'm going to open up. So over 1, up a half. Over 2, up 2, right? It's not up 4, it's up 2. It's half of it. Okay, so I'm counting from the vertex. Over 2, 4, 2. Over 3, 2, 2 and a half. Okay? Over 4, up 8. Okay, then I have my symmetry and I reflect it. Now I'm choosing 1, 2, 3, 4. 1, 2, 3, 4. Okay, so I'm choosing to reflect the easy points. Okay, there's my graph. That's your graph. Now, notice this graph is wider than the other graph because of the 1/2. The 1/2 made it wider just because of the way that it stretched those points. Okay, question.
So basically what you do is you square the x's first to get the y, and then from that you dilate it.
Yes. Okay, question.
Could you make like a new chart, like how you have like your original like x, y like coordinates, and like the graph or whatever that you do? Could you like do another one of those and like write the new points in that just to make it easier?
Sure.
Or like is that like
No, I got you.
Does that work to do it?
Sure. You can also just, here you go. Right, see, I just erased the ones I wasn't using. 0, 0, so 2, 2, 4, 8. Yeah, you could rewrite them if you would like. Okay, now let's do it. Open up times the y by a half. Okay, so then we get left 1, down 8. So my vertex is -1, -8. So my axis. Okay. So my axis of symmetry, because the symmetry is like actually how I get the rest of my graph. Okay. Notice it's an equation. Okay. And in order to actually get the rest of the points, I really do prefer the integer coordinates. Okay, so you can include extras, but make sure you include enough points where you're going to get integers. Okay, so I've got the, right, I got to times them by a half. And I'll just, right, there's my vertex. I'm just highlighting the actual ones that I'm going to put on the graph to make sure I've got enough integer coordinates. Yes?
Did you just do f of x equal x squared divided by 2?
Yeah, basically that's what you're doing. Which, okay, I could, if I know my numbers, 1, 1, halved, 2, 4, halved. You can do it all on the graph. Okay, 3, 4 and a half, 4, 8. Okay, so I'll just jot them. So I'm going 2, 4, 4, 8. That's what I'm counting. 2, 4, 4, 8. From the vertex. And reflect. And connect. Nice, smooth, concave up.
Wait, why did you write 4 next to the, so it only goes up 2?
This was 2, oh. Very nice, thank you. 2, 2. There you go. All right. Domain. Range. The minimum is -8, and that point, right? I want to make sure I know which one's the center. All real numbers. Range is from the bottom to the top. Notice how the range, it's connected to the min or the max one way or another. Question? Okay. Yes.
So the domain is always going to be on.
Yes. Okay, here we go. Person closest to the door. Explain to the person closest to the windows. How did we do the problem? First, second, third. Explain.
Basically, this shows you like good down and positive is up. But that's so you do the opposite of what this is saying. So like in the process, you do a negative, and if it's minus, you do positive, and then this, the K, Oh yeah, that's the up or down. And then
You
pretty much
square
just do that
x,
to the other way.
one square.
And then you do like what it does to the, you do that to the x
So
value.
you get 4. But in this
So you like
case,
half the x
it's
value. And then
half.
for
You
the
have
y
to half
value,
x. Basically, just do x squared divided by 2. And that's how you
Or I would plug in these.
All right. Are there any questions that need to be answered?
But that's
Yes.
all
since you're doing like you're halving x, what do you do to the y?
Oh, you're not halving x, you're halving the y coordinate. Because this is outside of the parentheses, so that's changing the y coordinate, so you're halving the y coordinate only.
And why did you do x 1/2?
I didn't do x 1/2. Okay, I'll come answer that question for you. All right, here you go. All on your own. All on your own. Question 3. Oh, okay. So we're plotting 0, 0, 1. This is, we're kind of ignoring this column now. Those are the points.
Okay.
Does that make sense?
Yeah.
So I'm just basically making a new y column by halving this. Oh, that's times. I'm sorry, that was a times. Times.
Oh, okay.
There you go. All right, all on your own. That's the first one we did. This is for next class. No, I'm just playing those. I'm coming, I see. Okay, you can go ahead, we're gonna do a little bit of computer practice after this example. I'll give you a little break from notes. Yay. Oh, your graphs look so good. Yeah, that's it. Vertex and 4 other points. Okay, hold on, no, not that one. Okay, you are moving your graph, not a curve. Okay, right?
I have that one.
But you started with the, it's not 2, 6. That's not what it is.
Oh,
Yes, I did deeper. Yes. Okay, where you start? Yeah, you forgot the stretch 3 times 3. Yeah. Hold on. Because you, hold on. Okay, well, times by 3 times that. Because you're right, it does look good.
Really bad.
Which is not, which is good to regulate.
I can't draw the
Yes.
U's. I can't draw the U's.
yeah.
Square it and then you multiply it.
Yes, 12. Okay, you can go ahead and open your computers. We're gonna check this one, and then we're gonna do, you're looking for 4.2 vertex form. Okay, we're gonna have a little, we'll just do work time. All right. Okay, so while you're logging in, you can put your attention up here, because I'm gonna graph it. So we're opening up, and we're gonna stretch by 3. So I'm gonna times the y by 3. 3 times y. All right, so I'm gonna go right 2, down 6. So I got a vertex, right 2, down 6. I'm opening up vertex. Okay, so it's going to go over 1, up 3, over 2, 2, 4, times 3, which is 12. Woo. Okay, I put my little axis of symmetry, and I reflect. Okay, so this point up here should be at the 5, right? If you're trying to check, that y-intercept should be at the 5. Can I not count? Oh, I can't count. 3, 4, 5, 6, 7, 8, 9, 10. It should be at the 6. Good. Thank you. I just couldn't count. Okay.
So do you go up 12 from the point that you were at?
Yes. So it was over 2, up 12.
Oh, so you do that from the vertex. Not
Yes.
from the
Yes. From the vertex. Okay. So 0, 0, 1, 1, 2, 4 times 3. There you go. Those are my points. Okay. Do you have to write all of that? No. You just have to make the graph. Okay. Let's see. Vertex. Axis of symmetry, x equals 2, and the minimum is -6, right? There's that vertex. Okay,